In this example, we'll try to understand how Scrambler works using an example. So the question is this: we have been given a function that is, say a function that is f is equal to d cube and d5. So the part 1 we have to design Scrambler, part 2 we have to find the output for a given sequence that is s, which is this. Third part we have to design Descrambler, and number 4 we have to find the output of Descrambler, that is r, and we have to show that r is same as that of s, which is this sequence. This 4 part we have to see in this example. So as your function f is given as d cube XOR d5, that is why the design is like this. Design is this. So the function of this Scrambler is your t is equal to s XOR with sd cube XOR with sd5. It is to be noted that initially your s is same as t or t is same as s. So that is why it is s XORed with sd cube XORed with sd5, and I can say this is s XORed with sf, and if this process keep going I can write this as XORed with sf square XORed with sf cube XORed with sf4, and so on. In other words, this is what is shown here. So your t from this particular Scrambler design is s XORed with sf XORed with sf square, because sf will come as the input, it will become sf square, where f is this, and then it will become sf cube, and so on. It will keep going till we'll get t. So actually we can easily find the output using a normal modular 2 addition, but the way we are doing here is easier and the chances of error will be less here. So this equation, say equation 1, is basically the equation of the Scrambler, and this equation gives you the output sequence t for a given s and function f. Now what we do is, what is f is given to us, then we will calculate f square as is given here, f square. So f square is what? Is f into f, where f is d cube and d5, d cube d5. When we multiply these two, we get d6, d8, d8 and d10. d8 and d8 would be 0, modular 2 addition, because of modular 2 addition. So what we get out of f square is d6 and modular 2 addition with d10. Similarly, we will do it for f cube, because in the previous equation we need to calculate f cube as well. So f cube is what? F cube is your f square into f. F square is already calculated, f is already known. When we put this value, we will get this. Then we will calculate f4, f raised to the power 4, which is actually is f cube into f. We'll put the value, we'll cancel the similar terms because of modular 2 addition, and then what we get is your f4. Similarly, we'll keep doing, and unless and until we keep getting terms which are less than d15, we will ignore all the terms which are more than d15. Why we will do so? We'll explain. We'll discuss that. So when we put all the values of f, f square, f cube as discussed now into this equation, value of f, f square, f cube into this equation, then what we get is, we get this equation. Okay, so what is this equation is? This equation is s is taken as a common, that is why it becomes 1 d cube, d5, d6, d10, d9. We can write d9 first and d10 later, then d11, d12, d13 and so on. Again I'll repeat, we'll keep all the terms which are less than d15. Why d15? Because our input sequence S has number of bits, that is 15 bits are there. Suppose S has number of bits which are 12, then we will keep all the terms which are d12. Why we will do that? We'll explain this. Now what we do is this: we have to implement this equation. How we will implement? First we'll write s, which is written here, then we will write sd cube, that is this. So what is sd cube? Sd cube is actually a sequence s delayed by 3 bits. So 1, 2, 3, 3-bit delayed. Again the same sequence will come, that is 1, 0, 1, 0. This will come here and this will come here and so on. In the similar way we will write sd5. What is sd5? Either sd5 is a sequence s delayed by 5 bits, or it is sd cube delayed by 2 bits. So what I do is I'll repeat the same sequence 1, 2, 3, 4, 5, and then I'll repeat the same sequence, that is s. Similarly I will write sd6, 9, 10, 11, 12 and 13. And suppose you get sd14 anywhere, then it should also come here. And if you get sd15, so what is sd15? sd15 is basically a sequence which is a sequence s which is delayed by 15 bits. So if you delay the sequence by 15 bits, then what are you going to get is, you are going to get all zeros. For example, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 times 0 will come, and then after the sequence will come. So we will not be able to add that. After giving a delay of 15, we will get all zeros. That is why we will consider all the sequence which are till 15. Even the sequence d15 can be neglected. So what is the next step? The next step is we need to do addition. So what we calculated is all this. We need to add them. What is the addition? Is a modulo 2 addition. So this, we will calculate number of ones in this whole row. So it is odd, that is why the sum is 1. This is t, that is sum of all these. Number of ones here is 0, that is 0. Number of ones is 1 here in this particular column. Similarly, in this case, number of 1 is 1, that is why t is 1. Here also 1. In this case, number of 1 is 2, that is why t is 2, and so on. So what is this? This is the output of Scrambler. The Scrambler, I'll repeat again, the Scrambler output can also be obtained by applying this sequence here and finding the output bit by bit. So I'll apply first, initially I assume all the register in reset state, and then I'll find the output 1 or 0, then I'll give a 1 shift, then this one will insert, go inside. This is also a procedure, but the probability of error in this procedure is high. That is why we will not be using, that is why we are using this particular method as we are discussing here. So I'll repeat again. What I have done is, first I have written this equation. Then I found the value of f square, f cube, and I'll keep all the terms which are less than and equal to d15, and even d15 can be neglected, and then after I will write them together. I'll write them together as is done here and sum them up, and I'll get the output of the Scrambler. So part 1 is done, that is designing the Scrambler. Part 2 was finding the output, that is also done. What is the part 3? Designing the Descrambler. If you remember in the previous lecture of the Scrambler, what we had done is the sequence, that is your S XORed with SF, that is equal to T. That was a sequence that we have seen in the previous lecture. That actually is a T. Now if we XOR SF on both the side, equation will remain balanced. So that become this, and that is equal to T modulo 2 addition SF. So if you see, this is actually SF XOR with SF. So this become S XOR 0, and that become T XORed with SF. Or if I use rather than, okay, so I'll repeat that again, how to design the Descrambler. So what is available with us is your S, and so from this Scrambler design, what we have T is your S XORed with your TF, okay, where F is D cube XORed with D5. So what if I XOR on both the side with TF? That gives S XORed TF XORed TF. So that gives T XORed TF, that is equal to S, because this particular part becomes 0, and as S XORed 0 become your S. And what is this? This is the equation of Descrambler, and this is what we are going to design here. So as can be seen, this is your S is equal to T XORed FT. So T XORed FT, T is taken as a common, so it become 1 XORed D cube D5, which is F. So this is the equation of Descrambler. So equation of Descrambler has T, then it has TD cube, then it has TD5. So for a given T, we will write T, then we will write TD cube. What is TD cube? Is actually a sequence T which is delayed by 3 bits. And then we have what is TD5. What is TD5? Is a sequence T which is delayed by 5 bits, or is a sequence TD cube which is delayed by 2 bits. So from here easily we can find the output. So this is a Descrambler design. This is a Descrambler design. We have seen in the previous lecture also. And what we need to do is we need to go for this T which is given here, TD cube, TD5. So 3 delay, 1, 2, 3, that become TD cube. Rest of the bits are same as T. Then 5 bit delay, 1, 2, 3, 4, 5. Rest of the bits are same, that become TD5. Now we need to XOR all this so that we will get something which is called as S. So this become 1, this become 0, this become 1, this become your this becomes 0, this becomes 1, 0, 1, 0, and so on, and finally you get 1, that is here. So what is this? This is a sequence S, and this sequence is it the same sequence as we have applied at the input? So we'll see this is the same sequence that we have applied. So this is how working of Scrambler and Descrambler is there. So what I mean to say, I'll give a brief. The first is we have to write the equation, that is as SF square, and then we need to find the value of f is of course given to you. Then you have to find f square, then you have to find f cube, and so on. You have to keep doing until you keep getting the term which are less than or equal to D15, and then you need to add them up. That will be the output of Scrambler. And while designing Descrambler, we will from the equation itself using this, that is the equation of Descrambler, and then we will design the Descrambler here, and we'll write the implement the equation td cube td5, and finally we'll get this. So this question complete. The question was design for a given f, design Scrambler, find the output of the Scrambler, apply the output to the Descrambler. So for that we have to design the Descrambler first, and then after we have to show that the output of Descrambler is same as the sequence S. This is what we have proved here. This is how designing of Scrambler and Descrambler is there.